the Institute of Engineering and Technology. Today we are going to study few more topics of multiple integrals. So let's begin with the first topic, that is change of variables in double integrals by Jacobians. In some cases, evaluation of double integrals become easier by changing the variables. Let the xy variable be replaced by a new variable uv by the transformation x is equals to f1 uv and y is equals to f2 of uv. Then this double integration f of xy dx dy is equals to double integration f of, now x is a function f1 of uv, so we will write here f1. Y is f2 of uv, so here we will write f2 into mod j du dv. Okay, where this j is known as Jacobian and it is given by the formula del of xy by del uv, and this we can express as del x by del u, del x by del v, del y by del u and del y by del v. We have to solve this determinant, okay, to find the Jacobian. Now using this equation number 1, the double integration can be transformed to a new variable, right? So what we are doing, suppose if we have x as a function of uv and y as a function of uv, okay, then we will find first this Jacobian. We have to substitute this Jacobian and we have to write this x and y in the terms of u and v, and we have to evaluate this integration in the new variable. Or if u is given, suppose in the function of xy, and v is given suppose in the function of xy, right? Suppose it is given in this form, then we will find this j dash, and j dash is what it is, del uv upon del xy, and this can be expressed as del u by del x, del u by del y, and here we have del v by del x, del v by del y, and we have to find this j dash, okay, and we have this property that j into j dash is equals to 1, right? Therefore your j is what? 1 upon j dash, okay. So if in the question u is some function of xy given and v is also some function of xy given, then we will find this j dash, and from this j dash we will find j by substituting j is equals to 1 upon j dash, and we will substitute in this formula to evaluate the integration. Okay, so let's begin with the example. Evaluate integration 0 to 4 y by 2 to y by 2 plus 1 2x minus y upon 2 dx dy by applying the transformation u is equal to 2x minus y upon 2, v is equals to y by 2, and we have to draw both the regions. Okay, so let's begin with the solution. Here u is given, that is 2x minus y upon 2, and v is given, that is y by 2. Okay, so here u is some function of xy is given and v is also a function of xy is given. Okay, so here we have to find j dash, and it is given by the formula del uv upon del xy, and this can be expressed as del u by del x, del u by del y, del v by del x, del v by del y. Okay, so firstly we will find this del u by del x, that is derivative of u with respect to x, and we will keep y constant. Okay, so this minus y is constant, derivative of x is 1, so 2 upon 2 it will give you 1. Okay, next we have to find this del u by del y, means derivative of u with respect to y keeping x as a constant. So this 2x is constant, so its derivative is 0, and the derivative of minus y is minus 1, so here we have minus 1 by 2. Next we will find this del v by del x, means derivative of v with respect to x keeping y constant. Okay, so this is a constant term, so its derivative is 0. And next we will find del v by del y, that is derivative of v with respect to y keeping x as a constant. So here you will have 1 by 2. Simplify this, so you will get answer as of j dash as 1 by 2. Okay, now we know this property that j into j dash is equal to 1. So your j is what? 1 upon j dash, and that is equal to 2, right? So this dx dy will change to mod j du dv, and the answer of j is 2. So it will become 2 into du dv, right? Now in the question it is given that this x varies from x is equal to y by 2 to x is equal to y by 2 plus 1. Simplify this. So multiply 2 over here. So you will get 2x minus y is equal to 0. And from here multiply 2 at these two places. So you will get 2x minus y is equal to 2. Okay. Now we know that this u is equals to what? 2x minus y upon 2. Right. So 2x minus y is what? 2u. Right. So in place of 2x minus y we will write 2u. So we have 2u is equals to 0. Okay, and again in place of 2x minus y just write down 2u. So here we have 2u is equal to 2. So from this you will get the limit of u as u is equals to 0 to u is equals to 1, right? Now in the question it is given that y varies from y is equal to 0 to y is equals to 4. Okay, and we have supposed this v as what? Y by 2, right? And so we can write this y as 2v, right? So in place of y here just write down 2v. So we have 2v is equals to 0 to 2v is equals to 4, right? So we will get the limit of v, that is v from 0 to v is equals to 2. Okay, now we will find the graph. Okay, so now here the given x is equals to y by 2, right? So from here you will get y is equals to 2x. So firstly we have to draw this y is equals to 2x, and this we can draw like this. Okay, next it is given that x is equals to y by 2 plus 1. So on simplification you will get here 2x is equals to y plus 2, right? So y is what? Y is equals to 2x minus 2. So we will draw this line. So this is our line y is equal to 2x minus 2. Okay, next we have y is equals to 0, that is x-axis, so we will draw here. And next is y is equals to 4, so this is your line y is equals to 4. Okay, and the intersection of this 4 line is the region R. Okay, now we are changing the variable to uv variable. So now we have the uv plane. Okay, and we have the lines u is equal to 0, so this is drawn. This is u is equals to 0, then u is equals to 1, so this is your u is equals to 1. Then we have v is equal to 0, this is v is equal to 0, and v is equal to 2, so this is your region R dash. Now we will evaluate integration over this region R dash. Okay, so the integration I is equal to 0 to 4 y by 2 to y by 2 plus 1 2x minus y upon 2 dx dy will change to integration 0 to 2 0 to 1 2u du dv. Okay, now firstly we will integrate this with respect to u. Okay, so what you will get, this integration 0 to 2 and this dv will remain as it is. Integration of u is u square upon 2, that 2 will get cancelled, so we have only u square, and the limits of u is what? 0 to 1. Okay, now substitute the limits, so you will get 1 minus 0, that is 1 dv. Okay, now again evaluate this integration, so you will get v, and the limits are 0 to 2. Okay, again we substitute the limits, so you will get answer of this integration as 2, right, by changing the coordinates to u and v. Okay, now we will solve one more example. Evaluate double integration over r x square plus y square dA by changing the variables where r is the region lying in the first quadrant and bounded by the hyperbola x square minus y square equal to 1, x square minus y square equal to 9, xy equal to 2, and xy equal to 4. Okay, so let's begin with the solution. Here x square minus y square is given and xy is given. So we will suppose this x square minus y square as u and this xy as v. Okay, so again we have this form, that is u is some function of xy and v is also some function of xy. Okay, so we will find j dash, and j dash is given by del uv upon del xy, and it is given by the formula del u by del x, del u by del y, del v by del x, del v by del y. Okay, so firstly we will take derivative of u with respect to x and we will keep y constant. So from this you will get 2x. Next, we will find the derivative of u with respect to y keeping x as a constant. So again from this you will get minus 2y. Next we will find the derivative of v with respect to x keeping y as a constant. So you will get here answer y. And derivative of v with respect to y keeping x as a constant. So you will get answer x. Okay, simplify this. So you will get 2x square plus 2y square is equal to, take 2 common, so you will get 2 into x square plus y square. Okay. Now we have this property, that is j into j dash is equal to 1, right? So from this you will get j as 1 upon j dash and that is 1 upon 2 into x square plus y square. Okay, now this dx dy is now converted to mod j du dv and mod j is what? 1 upon 2 x square plus y square du dv. Okay, now in the region in xy plane it is bounded by the curve x square minus y square equal to 1, x square minus y square is equal to 9, xy is equal to 2 and xy is equal to 4. Okay, so it is transformed to a square in this UV plane bounded by the lines. Now this we have supposed as u, right? So from this you will get u is equal to 1 and 2 u is equals to 9. Okay, and this we have supposed as v, so we will get v is equal to 2, 2v is equals to 4. Okay, now firstly we will draw the graph. So the graph of x square minus y square is equals to 1 is drawn in here. Okay, the graph of x square minus y square is equals to 9 is here. The graph of xy is equals to 2 is here and the graph of xy is equals to 4 is here. Okay, so for here, if your graph is in the form of x square minus y square is equals to, here we have plus a square. So the graph will be on x-axis like this. Okay, and if given x square minus y square is equals to minus a square, then your graph of this hyperbola will be on this y-axis like this. Okay, and if xy is equals to a square is given, then your graph will be like this. And if xy is equals to minus a square is given, then your graph will be formed like this. Okay, so according to this criteria you have to draw the graph of this hyperbolas, right? Now from this we have lines u is equals to 1, u is equals to 9. Okay, so this is your u equals to 1 and u is equals to 9. And from here we have v is equals to 2 and v is equals to 4. So this is your v is equals to 2 and v is equals to 4. Okay, so this is our region r dash and we will solve this integration over region r dash. So you will get this new integration as double integration over a region r x square plus y square. Now j is what? 1 upon 2 x square plus y square du dv. Okay, this x square plus y square will get cancelled and what remains is this 1 by 2 we will take outside of the integration and the limits of v, that is from 2 to 4, limit of u from 1 to 9 du dv. Okay, now we will evaluate this both the integration simultaneously because here we have constant 1. Okay, so you will get v and here u and the limits of v are 2 to 4 and the limits of u are 1 to 9. Substitute the limits, so you will get 1 by 2 into here 4 minus 2 and 9 minus 1. Simplify this, so you will get the answer of this integration as 8. Okay, so in today's session what we have studied, that we have given integration over r f of x comma y dx dy. Okay, so this is the, we will write in the form of f1 f2 and mod j du dv. Okay, so here x is given in the form of uv and y is given in the form of uv. Okay, so we will write like this. So firstly we will find this Jacobian by the formula del of xy by del uv, right? And this is given by the formula del x by del u, del x by del v and del y by del u, del y by del p. Okay, so we have to evaluate this Jacobian, we have to substitute it and integrate it. And if we have given that u is some function of xy and v is some another function of xy, right? So here we will find this j dash, and it is given by del uv upon del xy, and it can be expressed as del u by del x, del u by del y, del v by del x, del v by del y. Okay, and we have this identity that is j into j dash is equal to 1. So from this we will get our j as 1 upon j dash, and then again we have to substitute in this and evaluate the integral. Okay, so I hope you have understood throughout the session. Thank you for watching.